All right. We should be live. Welcome, everybody. I just want to give an update on the Blender Spaceship script. Blender Studio put together a really basic Spaceship. I mean, it's not super basic. It's pretty cool all by itself. Spaceship script that they provided for free. And I think you can download it without being a member of the Blender Studio. But even if you can't, I have transformed it to the degree that I feel like I can release it. So I've got a link in the description to my GitHub. And here's the thing. So it's basically a script that allows you to take an object. Let's see. Let's just duplicate this, put it over here, and we'll go into isolation mode. So this is, some sort of spaceship thing, and it's generated from this underlying geometry. You can't see it very well, but it's basically these 4 points. Let me just turn this off in edit mode. There we go. It's these 4 points here, and single face. And if you put the geometry node spaceship generator modifier on it, then it turns it into this. And it does that with a few cool tricks, which I'll walk through and show you how it does it. So since I've worked on it last or shown it last, I think I did a short stream on like design continuity and procedural generation or something like that. And that one, since I showed it in that one, I've added a few things. I've added greebles, so there's all these little black greebles here. And I've added engines, so there's these engines in the back. I've added some options for aligning. Let's see. You can do the engine alignment, so it's not aligned. See how these are all just like rectilinear, vertical, or you can line it up with the rotation of the main spaceship bulk. And I've added antennas. You can see the antennas sticking out from the bottom. And what else? Is it basically it? Oh, I guess I've broken out a few of the procedural generation things, so you can modify them in different ways. Change the seed. Oh yeah, that was one of the major ones. So I changed the base seed, so you can change the base seed here. But then if you get a design you like that's pretty cool, then instead of but you want like different greebles or whatever, you can change the greeble seed separately. So it'll just change the that's the density greeble seed. There we go. So you can change the greeble seed, and that changes both the greebles for the black section and the greebles that it uses to subtract from the main bulk, but it doesn't change the main structure of the greebles. So you could do anyway. That helps you to kind of fine tune the design. If you're like, oh, I really like this, but I want the fine details to be different. And so let's go through in detail how this all works. So the first thing is, of course, that it's based on this mesh. So we could like change this mesh and maybe like add it off to the side like this, and then that should change. Yep. So now it's got more stuff off to the side, and we could like move this way forward, and so now it's going to have this different shape where it's got kind of this long thing in the front and the wing on the side, and that will be so that's what it's based on, kind of the basic form. So that's actually kind of cool. I kind of like that. Maybe I'll keep those changes. So then what it does is it runs it through. So that's the base geometry, and then it runs it through this spaceship generator geometry node thing. So let's go through what all that does. So the first thing is it grabs the input parts. So let's go over and look at those. Those are spaceship input parts, and here they are. So there are 4 different shapes, very basic shapes, this kind of boxy shape, and I've named them boxy part, long, strut, slim wedge, and thick wedge. And so those are the 4 parts, and you can add as many parts as you want. You could add more to these, but those are the parts that it uses for the main structure and for the Boolean subtraction greeble step, but it doesn't use them. I mean, you could have it, but it doesn't currently use it for the black greebles. The black greebles are just cubes, and I'll show you that later. So anyway, so those are the 4 basic shapes, and it's the same idea as the Blender script, the base Blender script. I've modified them slightly so that I think they fit together better. But that's basically what they had, to start with. Same idea. So you've got this collection for Spaceship structural parts. And then while we're doing the collections, let's look at the engines too. This is pretty straightforward. It's just a couple of engines. And I kind of designed them to have a little bit more detail. So here's this 3 engine nacelle and the single engine nacelle. And those are the 2. And of course you could add more types of engines, but I feel like it looks pretty good with just these two types. So then you can, so that's the basic stuff. So let's go back to our ship that we're working on. So that's what it does. It's got the input parts, and this thing isn't actually really necessary, all this switch and stuff, but it's basically if the domain size for the input collection is 0, equal to 0, then it uses a cube instead of geometry to instance. Oh yeah, it creates an instance of a cube instead of creating instances for all the objects in the collection. So it's just like a fallback basically if you don't have anything selected. In fact, let's demo that. So if you've got Spaceship structural parts and you decide to just like, nah, I don't want to use those, it'll just use cubes. And it looks all right. It's a little bit disconnected, but it's still actually pretty sweet. So Spaceship structural parts. So I mean, like, there's just so many things you could do with this, right? You could change the structural parts. You could mess around with that. So anyway, so that's the input stuff, and then the input goes 3 separate ways. It goes up to the base layer, and then it goes over to the subtraction layer. So basically it does the base layer next. So the base layer is, let's see if I know there's a way to like change the output so that it, like from the current node, let's see if I can just figure that out real quick. Output, group output, Shift A. Is that right? No. Output to all outputs, numpad / Is it gonna work? Oh no, that adds reroutes. I mean, that's kind of cool also, but it's not what I wanted. Let's see. Output, switch node type, output viewer. Nope, not an easy way to do it. So we'll just do it the hard way. I'm going to grab the output over here, and I'll move it over here. No. And we'll just output it to that thing manually. So you've got your base parts, and then you've got the base geometry. Here we go. I'll just slap this in there. There. So that's what the base geometry looks like. It takes a bunch of points. It distributes it on the base geometry, the one that we were showing earlier, this geometry. And then and you can see this kind of goes up here. So if we like, let's turn this back on in edit mode. So now if we move this up, it's changing how this is connected up, right? So we can kind of mess with this, maybe. Oh, that's kind of cool too. They're all kind of cool. I don't know what I'm saying. All right, so that's the base geometry. Distribute points on faces, instance on points, realize instances. And this will show up several times in the script. It's the basic form for getting these parts kind of layered out like that. So you've got that thing, that's the base layer. Then it's got 2 things that it does with that base layer, or maybe 3, at least 2 things it does with the base layer. One of them is it creates the structure, the internal structure, and the additive greebles. So let's look at that. It does the same thing. So first it extrudes the mesh. So it takes the mesh, that base mesh and extrudes it inward. So you can see it just gets a little bit smaller. And that's the offset scale of -0.3. Then it transforms it, and I added this. I just feel like it looks a little bit better if it goes down just a little bit so that the underside of the spaceship is more dark and the upper side is more light. It just looks better. It looks more like an animal, because animals are like that. Or are they light on the bottom? Animals are lighter on the bottom. But anyway, it looks better. It's got like, the complicated bits on the bottom and kind of like smooth surface on top, kind of like a tortoise shell or something. So that's what it does. It moves it down just a little bit, and that's not a lot, and it also isn't scaled to the size of the spaceship parts, so that could be done better, but it works for now. And then it's got a group input for the greeble seed, and it modifies that greeble seed a couple times so that you don't use the same seed for this and for the subtractive greebles. And then it distributes points on faces and instance on points. And this time it's instancing the same set of those spaceship structural parts, but it's instancing them at a smaller size. So you've got the greeble scale here. And so if you modify, well, let's see. We're going to take a look at that. Distribute points on faces, instance on points, and realize instances. So that's all those greebles, all those little greebles. And that is the greeble scale, I think. Yeah, so if you scale this up and down, changes the size of these. And then it does the same thing again so these are the greebles that are being instanced on the structural layer. And it's just a cube. And then it does the same thing again, but for a different set of scale parameters, so that these are a little bit taller and these are a little bit longer. And then it adds those together so that you get, instead of just a bunch of cubes, which kind of looks boring, you've got a bunch of cubes that are added on top of each other. So you've got like this, you've got this tall one and then this long one, or you've got, I might be able to make those wider. I don't know, it looks all right. So you've got like these kind of shapes, right? With the tall ones and long ones and tall ones and long ones. So it makes them, it makes it look a little bit more designed as opposed to just having like a bunch of cubes everywhere. And we could add more of these, or do a bunch of instances with a bunch of different scales. I probably, instead of doing 2 of these like this, I should use like a mesh line and then use instance on points to add a bunch of instances that are individual, on each point. And so that way you can easily change the number of greeble cubes per instance. But I only had 2 that I wanted to do, like the tall one and the long one, so I left it like that. And then it also adds in the structural thing. And then the last thing it does in this step is it just changes the material. And it changes that kind of dark material so that it all hooks together and kind of meshes, kind of gels. And that is the structure and additive greebles. So that all is getting added into the spaceship. And what it's getting added to is the base mesh that has been modified by the subtractive step. So this is basically the main work that happens here is the mesh boolean, and this is the thing that takes the most time in the script, is this boolean step. Everything else takes, as you can see, like 2.5 milliseconds, 1.5 millisecond, 1.5 thousand or 100 milliseconds. It's like 1.5 seconds to do this. Just this Boolean step here. So this is the expensive part of the script. Everything else is basically for free and super fast. But it makes it look super amazing. So this is the base. You can kind of see the same base mesh here. And let's go over and pull that in again just so you can be reminded of what that looks like. The base mesh here. And then it's got the same idea. It takes the base mesh, distributes some points on faces, instances those same geometry, the structural geometry, realizes the instances, and that's what it looks like here. So that's all those little parts. And then it subtracts that whole thing from the base mesh, which is this mesh Boolean step. And again, that's what takes all the time. So that gets subtracted out. And then we add all that together here. And there's a little bit of complication with the parts going all over the place because the antennas get added in, but they don't get rotated. because it looked weird if the antennas were like sticking inward and down or outward and down from the parts that were rotated. So I think they look way better hanging like straight down. And so that's what that step is this is the antennas. And the same idea, you take the input, you subtract it. What's this? Subtract. We'll see antennas. Oh yeah, so this is a math operation. So the antennas, well, let's look at the antennas here. Where's my group output? I put it somewhere. Here we go. Over here. Okay, antennas, transform, instance on points, realize instances. Here we go. Let's just grab the antennas. So here's the antennas, and they are instanced on the same points that are being used for making the greebles. So they'll each hang down, those cubes that were there, they'll each hang down from one of the cubes. And then I modify the point cloud, I delete a random number of them based on this antenna value. So 0.185, if you crank this all the way up to 1, then it's got an antenna hanging down from each one. And if you set it to 0, then there are no antennas. So that's pretty straightforward. Maybe 0.2, it should be fine. And those each have a slightly randomized scale. So they're randomized from, cube. It's basically just a cube that's randomized in scale. Big, long, tall cube. And then realize those, set the material, and then the switch is for if this is set to 0, if the fraction is set to 0, then it doesn't bother to do any of this. It just has no geometry. Doesn't do anything with it. So that's the antennas. And but those are getting the rotation here. You can see in between here, there's this rotation, and that's in the rotation step, which is the next thing to talk about. Or I guess we could talk about the engines. The engines also have this hook into the rotation step, and then they also have a bypass. So I've got two switches coming out of the engines, kind of jumping ahead here, but one of the switches goes directly to the output without rotating. But then in order for the engines to be in the right place, you have to rotate the point cloud, and that's what this does. And then if you don't rotate the point cloud, if you just rotate all the engines with everything, then this goes into the geometry that goes into the rotation in the first place so that you don't have to worry about it. So let's look at the engines real quick. It's basically the same idea. The only tricky thing here is that I take the, where is it? I take the position, I separate the X, Y, Z and get the Y value. I figure out what the minimum Y value is and the maximum Y value is for the whole geometry cloud. So that's the whole point cloud. So I basically take like the back, 10%, the rear 10% of the point cloud, delete all the rest of it, just keep that rear 10% and use that for the engines. Because you don't want engines all over the whole ship, you just want it on the back of the ship. And so that's what that does, that whole thing there. And then, so you delete those points. I could use a selection, but I found that, I don't know, for whatever reason, it seemed to work better with just deleting the points instead of having the selection. So that's what I do there. And then either you rotate it here or you output the geometry and then rotate it later. And it's the same thing, instance on points, except this time the instance is instead the collection info for the engines collection. And so that's the Spaceship engines collection, which we looked at earlier. So so again, you can add engines to the engine collection and add to the library of engines that it'll select from. So that's those. And then it, like I said, it either exports directly to the geometry or goes into the rotation. So let's do the rotation. And this is pretty straightforward. We should look at the engines just so we can see the output from this step. Let's see, I have engines rotated are on. So that's going to be this output here. So there's the engines. And then here's the engines that are rotated, and it gets transformed with the rotation thing, but it doesn't get the instances don't get transformed, just the point cloud gets transformed. So it gets transformed before the point cloud has instances on it, so the instances don't get rotated. Okay, so then we have the rotation. So we've got all this stuff coming in to our, let's move this up here a little bit. Got all this geometry coming in. So this is the, well, let's just look at it. This is the geometry that we have so far that we haven't rotated or anything, or transformed. So we've got this spaceship, and it's a half a spaceship, basically. It's got this whole thing. It's got all the greebles, it's got all the cutouts, it's got all the engines, but that's it. It doesn't have any symmetry to it. So we want to make it look symmetrical because that's part of the thing that makes it look cool. So we take the geometry, we go in here and transform it, and we transform it with, what is this, random value engine rotation. Rotation, oh, okay, yeah, rotation. So this is the rotation. If we're using rotation, rotation override, and this is the rotation value. Okay, yeah. So I added a rotation here. Let's get the output of the rotation here. So by default, it just selects a random value from negative 0.8 to 0.8 and inputs that for the just on the y-axis and puts that into the rotation slot of this transform node. You can see the rotation right there. So let's look at that. That just is the default stuff. And so it takes that, rotates it. Pretty straightforward. I've got an override in here. So if you add the override, then you can manually rotate it however much you want. So you can, twist it however much you want it to do. And you can also rotate it instead of on the Y, you can also rotate it on the X and Z axis. And you can get some cool effects. I'll show you one of the demo things that I did for this in a bit. So let's turn off the override. We'll just leave it with the default. And then checks the bounding box for the geometry and gives it, finds the minimum and the maximum for the bounding box, the X location. So that's this location this way. And then it does a map range with inversion and combine for the translation. So that is, let's see, transform geometry. And that also goes into this transform and this transform. So these are all the same transform basically, but they're operating on different geometry depending on what options you have. So let's look at that output. And that basically allows you to decide how far out from the center you want the spaceship to be clipped along the vertical plane. So you can't really see it right now. So let's go over to the join geometry here. No, let's go to the bisect. Okay, so the last thing, I'll show you in a minute how that translation works. But the last thing it does is it inserts a grid. It moves that, rotates it 90 degrees, and then it does a Boolean with the whole mesh, all this stuff along the center axis, and then it makes a copy of that mesh, scales it -1 along the x-axis, and joins those together. And that's how you get lateral symmetry. So let's look at that. And it's what you'd expect. It's what you've been seeing the whole time. The whole thing is symmetrical along the x-axis. But the thing that's cool with the this whole thing about finding the bounding box and doing a map range is that you can have a control that says lateral offset, and this can go from 0, where it's just touching right in the middle on a single vertex. You wouldn't want that ever, I'd imagine, but you can have it. And you can also override this. I think you can override it, lateral offset. -0.1. Should be able to enter an override. No, it doesn't let you. Okay, well, you can always change the group input so that you could override that if you wanted it to have like 2 separate parts that were completely disconnected for whatever reason. And then the lateral offset goes up to 1. And if you set it to 1, then there's no spaceship because it's offset all the way the other way. But that lets you decide, if you want it like 0.6, this is going to be really crunched toward the middle. So now it's just the parts of the spaceship that were out from the center like that. And this goes down to, I like to set it around, like 0.15 or so. And that seems to work pretty well. So why did I put all these options in here? Well, aside from being able to tweak stuff, it allows you to do some more of the spaceship design kind of things that I was talking about in the last video. So here we've got a series of spaceships. Let's just look at those by themselves. And you can see they kind of look like, oh yeah, they're the same class of spaceship, or they were all kind of designed with the same idea. And that's because they all have the same base seed. So these are all negative 116, and those are all the same base seed. But you can also see that they're kind of different, and it's like, oh, well, these aren't exact copies of each other, just scaled up, because that would be boring. They're slightly variations. So one of the things is I've got an override. I've got the rotation override, and I use a different rotation for each one of these. So you can see this is 0.3, that's 0.37, that's 0.5, and that's 0.74. So they get more rotation as they go up. They also have a different lateral offset for each one. So the more lateral offset you have, the more like spindly and disconnected the spaceship will be in general. And so this one, the big ship has, you can't have a spindly big ship. It's got to be dense and packed together. So it's got a lateral offset of 0.2 and all the way down to lateral offset of 0.07 for the little spaceship. So it's a slight change, but it's significant. It makes it changes the look of the ship. And you could change this for the big one. Maybe you want it to be even more. So you could be like, this is, offset of like 0.25, and this one could be like 0.3 maybe. And so now it's like, okay, yeah, this is like really packed together, and because it's a big ship and you can't have like a bunch of stuff hanging out. So that's cool. It allows you to, kind of have those slight variations and stuff. Also, they use a different Greeble seed, and they use a slightly different Greeble scale. I showed that off last time, I think, the Greeble scale modification. And it's got different numbers of antennas. So the big ship's got more antennas than the small one, even proportionately for the number of Greebles it has. And what else? Yeah. So anyway, so that lets you have like this whole class of ships that are the same ship, or the same design, but has a different, different scale, different ship class, or whatever. And so that's the main thing that I wanted for all those controls, is so that I could have random variations without it being completely random, so that they had just completely different designs every time. And so that's one of the things. And then the other thing is, with the rotation override, you can do cool stuff like this, where you've got, I've got the engine rotation override turn off, and I've got this thing kind of rotated inward. This is, negative 0.4 on the z-axis. So it kind of has a wedge shape. And then you can also do like really fun stuff like this, where it's rotated up on its side. This is, 1.8, so that's spun all the way over forward, and, kind of facing forward design. Super non-aerodynamic, but, it's a spaceship, so that's fine. And, yeah. So that's the spaceship script currently as it currently stands, how it all works. I'm thinking about adding a little bit more stuff to the antennas, maybe having it do some proc gen on the antennas themselves, so they're not just like sticking down. They've got maybe little cross beams or little spheres on them or whatever to make them look a little bit more cool. Thinking about adding some guns, thinking about adding maybe some crew space kind of stuff with windows in it. I don't know, maybe, that kind of thing. But if you have any questions, you can comment in the comments, or hey, Flying Savannahs, you still on? Maybe you are. Cool. Hey, yeah. Oh, yeah, the 3D printed Escher thing. Cool. Did that turn out well? I hope it turned out well. Yeah. Well, it's pretty easy once you've got it set up. He's saying that it makes it look easy. It's really easy once you've got it set up. You can just take this and be like, all right, I want to change the base seed, and get a different spaceship design. There we go. There's a different spaceship design. They're all so cool. So it's easy once it works. Tuxedo cats are pretentious on the top and the bottom. Yeah, exactly. Yeah, these ones are a little bit, maybe a little bit over the top on the greebles, but you can always scale it down. You just tune down the greebles. So anyway, yeah, if you have any questions about this, you can comment on the video, and I'll be happy to respond to it. There's also yeah, you're still here. Cool. There's also the GitHub, so you can submit an issue on the GitHub if you want to do that. This is all hosted on GitHub, and it's just a Blender file. You'll need Blender 3.2, I think, and of course, always get the latest release if you can, so that it all works better. And hopefully, this will continue to develop. I've been having a lot of fun working on this. Yeah, guns, crew quarters, and those are basically maybe like cargo containers or something. Could do that. Yeah, it's been sweet. So, hope you all enjoyed it as much as I've enjoyed making this, and I'll talk to you later.